Okay, here's my attempt at the last probability question. It's pretty darn tricky. I just watched a teacher who was pretty darn good at math kind of mess up at it. And, well, I think they messed it up. Maybe mine's messed up. I don't know. But here's my explanation for the last question. There are 10 learners in a line. How many different ways can you arrange those 10 learners? I hope everybody got that. 10 factorial, which is 3,628,800. But what's the probability that there'll be 5 learners between the 2 youngest learners in the line? I like to look at the boxes, the different ways it can do it. And I put 2 green boxes for the youngest learners. Let's say 1 is the youngest learner and 2 is the second youngest learner. Well, that's one way to do it like that. Well, this learner could move over here, and you could have these 5 here. The youngest could move over here, and you could have 5 here. Then they could move over here. That looks like it. Now, I look like I am looking at here 4 combinations. And in my probability, I put the total number of arrangements on the bottom, 10 factorial. I agreed with the other teacher that did it. He put 10 factorial on the bottom. He would come up with 4, but I see 4 different ways we're looking at it. And there's 2 different ways the youngest and the second youngest can be arranged. So that's why it's times 2 or 2 factorial, same difference. But you've still got 8 other people in here that can be arranged in all sorts of different ways. Oh, how many ways can you arrange 8 people? 8 factorial. So this is my best shot at it. 4 times 2 factorial times 8 factorial, all over 10 factorial. I put it in my calculator, and the probability that there are 5 learners between the 2 youngest learners, I think, is 4 out of 45. So I'm not sure that's right, but it sure sounds good to me.